Hi, welcome to Number Club. This is Year 1 Pure, Chapter 3, Lesson 1, and today we're talking about simultaneous equations on graphs. Okay, that easy, let's get started. So we've got to plot the lines on the axes. You should recognise this from GCSE. We've got two linears, and so we have x equals and y equals. When x is negative 2, negative 1, 0, 1 and 2, these tend to be the values that I substitute in. So we're going to try the first equation first. So we've got, I tend to go with 0. 2 lots of 0 plus 6 is going to be 6, and then I spot the gradient being 2, so it goes 6, 8, 10, 4 and 2. Obviously if you're not comfortable with that, just substitute it in, okay, and you'll find your answer in the end. So there we go, we've got a line that looks like that, and so we're going to join it up. Obviously you should use a ruler, but I don't have one at the moment on this thing. So let's move on. We've got y equals 3 minus 4x. I like to write that as y equals negative 4x plus 3 because that way it shows me my gradient a little bit easier. X, y, negative 2, negative 1, 0, 1 and 2. Don't panic if some of these go off the bounds of the axes, it doesn't really matter. We get 3, we're going to take away 4. Negative 2, 11, negative 1, 7. Okay. 0, 3, negative 2, 11 obviously didn't fit on there. 0, 3, 1, negative 1, and 2, negative 5. And so we're going to get a line that looks a bit like that there, or something probably better if you used a ruler. That there is the solution to the simultaneous equations. It is the point negative 1/2, 5. The solution to the simultaneous equations is quite literally which value do I need to use so that I get the same output from each equation. So which value of x do I need to pick so that I get the same y for each equation? And it's negative 1/2. Okay? If you're ever asked, say, if we called this line 1 and called this line 2, when is it that line 1 is greater than line 2? Or when would it be that line 1 would be greater than line 2? It would be when x is greater than negative 1/2. Okay, you could be asked things like that. So when is it that line 1 is greater than line 2? Well, it'll be when is it that it's above it. Okay, moving on. Plot the graphs on the axes and indicate the solutions to simultaneous equations. Now, this is quite simple stuff. I'm not going to show you all of them, the kind of messing around with graphing this stuff. I think it'd be a little bit of a waste of your time. So it's not there, sorry. It's there, just like that. And when we've got 3 going in, it comes out as 5. There we go. And when we've got negative 3 going in, we get 5. So this will be the curve. What about when 4 goes in? 4 squared, no, that's too big. So we get the curve. Will come out, whoops. Let's erase that bit, that was no good at all. The curve will come out looking a bit like this. Okay, sometimes these are a little bit awkward to draw, but there we go. So we've got something that looks a bit like that. That'll be the curve. Obviously it's easier on paper. And then we've got the linear, which is x plus 2, so we get that thing there. Okay, it just goes off like that. Okay. There we go. So the point of intersection from these two things, there are 2 of them. Okay, one of them is when x is negative 2 and y is 0, and the other is when x is 3 and y is 5. Okay, think about it. Try and substitute those things in. If 3 squared take away 4 is 5. 3 plus 2 is 5. Happy. Okay, negative 2 plus 2 is 0. Negative 2 squared is 4, take away 4 is 0. Okay, you could obviously, you're supposed to use substitution tables for these things, but I thought it'd be a little bit of a waste of your time to watch me fill one of those in. Alright, moving on. Plot the graphs on the axes and indicate how many solutions exist to the simultaneous equations. Now, y equals x squared is a really easy one to plot. You should really be getting used to plotting these things pretty quickly, but you should still be using the table. For me, I'm just going to graph it double quick so you don't have to watch me fill in a table. There we go, we've got that there, but under ordinary circumstances I still would use that table. Okay, and then we've got x squared minus 1. Now I'm not sure about x squared minus 1, so we get x, y. negative 2, negative 1, 0, 1 and 2. So when x is 0, y is negative 1. When x is 1, y is going to be a half, take away 1, which is going to be negative a half. Okay, we're going up by halves each time, obviously, aren't we? Okay, negative 3 over 2, negative 2. All right, so we've got negative 2, negative 2, negative 1, negative 1 and a half, 0, negative 1, 1, negative a half, and 2, 0. And so this will be the line. Okay? How many solutions exist to those simultaneous equations? 0. There are no solutions to those simultaneous equations. Okay? They do not exist. You can, if you want to, try out the discriminant on it to double check that there's no solutions. You could have x squared is going to equal x over 2 minus 1. X squared minus x over 2 plus 1 equals 0. 2x squared minus x plus 2 equals 0. You don't have to do this step to use your discriminant. You could still use it with the halves and whatever else, but I just find it a bit easier. B squared will be negative 1 squared minus 4 lots of 2 lots of 2, which is going to be 1. Take away 16, which is negative 15. So if the discriminant's negative, there's no solutions. You don't have to do this thing. You can use the graph for it. Okay? So, moving on. This is an exam question. The curve C has equation x lots of 5 minus x. So that's nice. That's interesting. Watch out for the negative. And the line L. Watch out. That's not y equals. It's 2y equals. Use algebra to show that they do not intersect. Now a hint there is using algebra to show that they do not intersect would be substitute one into the other, tidy it up, produce a discriminant. Wherever we're talking about things being do not intersect, we'll expect that discriminant to be negative. And then for B, sketch them. Now with B, you need to watch out for the negative part in the curve, and you also need to watch out for the 2y equals. Right, I'll pause there. I've given you enough of the hint, so try it out. All right, so use algebra to show that they do not intersect. So first up, if y equals all of this stuff, we've got y is going to equal x lots of 5 minus x, and also 2y equals this stuff here. Okay, now I'm going to say that y is going to equal 5 over 2x plus 2. That way I can just glue these things end to end. I do not want to isolate x in my linear. If I isolated x in my linear, it'd be 2y minus 4 all over 5, which equals x. That's horrible in itself, but then to substitute it into here, again, extra horrible, no good at all. So I've decided to isolate the y because it's much simpler looking in the curve. Okay, this is still isolating y, even though it's just by itself anyway. We're isolating y here, you see. Okay, so we've got 5 over 2x plus 2 is going to equal 5x minus x squared. That will mean x squared plus 5 over 2x minus 5x plus 2 equals 0. So I've moved this over from negative to positive. I've moved this over from positive to negative. Okay, we'll get x squared minus 5 over 2x plus 2 equals 0. And we're going to use a discriminant here. You can use a discriminant with it as it is if you want to, or you can use a discriminant with it with 2x squared minus 5x plus 4 equals 0. Now, I don't know what most people would kind of go with, but for me, I tend not to like the fractions, so I'll go with this. And I'll produce a discriminant for that. Okay, it's fine to do that sort of thing. It's okay. So we get b squared minus 4ac, and we'll see how that relates. So we're going to get 25 minus 4 lots of 2 lots of 4. 25 is negative 5 squared. 25 minus 32 is going to equal negative 7. Since discriminant is less than 0, no solutions / intersections exist. Okay, not too bad. Alright, sketch C and L on the same diagram showing the coordinates of the points. Now, sketch is not the same as draw, which is what we've been doing previously, but this is still important for us to be able to do. So sketch, well, the curve has solutions x equals 0 and x equals 5. Okay, we have 0, we have 5, and it's an n-shaped curve. So you have something that looks like that. Now what that means is I'm going to expect the line to go somewhere off up like that. If the line's got a negative gradient, there's solutions. If the line's got a y-intercept that's negative, there are solutions. So I'm going to expect it to go off like that somehow. So let's take a look at it. We've got 2y equals 5x plus 4, y equals 5 over 2x plus 2. Okay, we want to meet the axes, so we need to find out the y-intercept is 2. What's the x-intercept? Now the x-intercept occurs on the x-axis, so that's when y is 0. So 0, x-intercept at 0 equals 5 over 2x plus 2. So we'll have negative 2 equals 5 over 2x, negative 4 over 5 equals x. So that'll be negative 4/5, and it'll be 2. So the line will go off like that there. Okay, where there's no points of intersection. All right, all done. So thanks very much for watching. Visit numberclub.org to find some more videos and tasks just like these ones. If you get a chance, subscribe to the channel. Thanks very much for watching. Hope it helped. Thanks. Bye.